Here is another interesting question that I wanted to go over with you for our finals or for your AP exam review. And in this question, they say a bead of mass M slides without friction on a vertical hoop of radius r, and the radius is given. The bead moves under the combined action of gravity and the spring attached to the bottom of the hoop. Assume that the equilibrium length of the spring is r. So when the spring is relaxed, its length is r, where r is the instantaneous or relaxed length of the spring. The bead is released at the top of the hoop with a negligible speed. And then how fast will it be moving at the bottom of the hoop? So I'm going to look at the potential and kinetic energy right here and over here. If the speed wasn't negligible, and I'm going to solve this question if the speed wasn't negligible. So then that means the bead would have some kinetic energy, which is 1/2 mv squared, and that would be the velocity of the bead at that moment. And if we assume that potential energy of the bead at this position is equal to 0, then the potential energy of the bead at the top of the hoop is mg, and 2 times the radius, that's the height. And then also the spring is stretched, so the spring equilibrium length would be r, and at that position all the way on the top, the potential energy of the spring would be 1/2 k, and then x squared, the potential energy of the spring formula. For x, you have r squared. So this is the total energy of the system, or mechanical energy, when you start all the way at the top. This is how much energy you should have at the bottom, because energy gets transferred from one to another. So here we have on the kinetic energy all the way at the bottom, and the potential energy of the spring is still the same. So potential energy of the spring, now it is compressed at the bottom because the equilibrium length is r, so at the bottom it would be compressed. So it's still 1/2 k and r squared. The force is just acting in a different direction. So the force of the spring, if you remember that formula, the force of the spring is equal to negative kx, but the potential energy of the spring is equal to 1/2 kx squared. So the kinetic energy here is going to be bigger than the kinetic energy at the top, then equals to 1/2 m, and I'm going to call this one the bottom b squared. If I compare these two energies here, then I see that potential energy is missing at the bottom. It equals to 0. That means all this potential energy went into the kinetic energy at the bottom. And then potential energy of the spring was the same for the top and bottom. So if I set them equal to each other, those two just will cancel each other. So what I will have, if I set them equals to each other, I have 1/2 mv squared. And if you don't have velocity at the top, then that would become 0, plus mg 2r, that's potential, that's the whole energy, mechanical energy at the top, equals to 1/2 mv and the velocity at the bottom. Then every single term has an m, so I can cancel the m's. Times them all by 2, I will get v squared, that's velocity at the top. If it is 0, then it is 0, plus 4 times, if I times it by 2, rg, and equals to velocity at the bottom squared. So the velocity at the bottom squared, or the velocity at the bottom, is equal to the square root of v squared plus 4rg. In this question, you have a mass of 5 kilograms hanging with some system of multiple pulleys, and they're telling you that they will pull this mass with a force of the tension of 10 newtons. And the question is, what's the acceleration of the mass? So if I look at the rope, anywhere in the rope, the mass is going to be, the tension is going to be 10 newtons. So that means here I have 10 newtons, and here I have 10 newtons, and this one is 10 newtons, and every single one of these tensions in the rope is going to be 10 newtons. So I see upward force is 1, 2, 3, 4, 5, 6 of 10 newtons. So upward I have 6 times the tension, so it's for F net is equal to MA. And downward force I have only mg. So minus mg is equal to MA. So your net force is equal to MA. So 6 times 10, because the tension is 10, minus 5 times 10 equals to the mass times acceleration. So you have 60 minus 50, which is 10, equals to 5a. So a is equal to 2 meters per second. So acceleration of the block is going to be 2 meters per second. In this question, and I have seen similar questions on AP exam, and you might have similar on our benchmark and midterm. In this question, they ask you, so if the car was moving starting at 8 meters per second, so you see this on the graph at time equals 0, and has velocity of 0 meters per second at 4 seconds, and then looks like the car did not move between 4 seconds and 6 seconds because the velocity between 4 and 6 is 0, and then starts moving at some velocity, at some acceleration. So the velocity initial is 0, but then you see it starts moving at some acceleration because the velocity is increasing in the opposite direction, in the negative direction. And then the question is, how long will it take the car to come back to the original point where it used to be at time equals 0? So in this question, I'm going to calculate what distance the car traveled over the first 4 seconds. So if I want to calculate the distance car traveled over the first 4 seconds, so between 0 and 4 seconds, I have average velocity times the time. Initial velocity is 8, final velocity is 0, and the time is 4 seconds. Divided by 2, that's average velocity. And the time is 4 seconds. So I will get 16 meters. So the car was moving in the positive direction and moved 16 meters over the first 4 seconds. Then the car continues moving after 6 seconds, but in the opposite direction because velocity is now negative. So the direction in the other direction, or the motion in the other direction, continues. And I want to know how long it will take before the car comes back to where it used to be. So if I do my calculations, the distance traveled after 4 seconds, so I'm just write 6 and on, so 6 and on, equals to average velocity again times the time. The time is the part that they ask me about. So that is initial velocity, which is 0 at 6 seconds, plus the final velocity divided by 2 times the time. So initial is 0 because at 6 seconds the velocity is 0. And then the distance from 6 seconds on can be written as v final over 2 times the time. But final velocity is equal to initial velocity plus the acceleration times the time. But again, initial velocity is 0. Then I can say that the final velocity is equal to acceleration times the time and plug it into my equation. So the distance traveled after 6 seconds on is equal to, instead of the final velocity, I have acceleration times the time over 2 times the time, or 1/2 at squared. Now I have to find acceleration of my graph right here. So acceleration is the change of the velocity over the time. It's actually the slope of the graph, because your rise is velocity, so your rise is velocity, and your run is the time. So I have acceleration is equal to, if I look at this triangle right here, then my rise is, I think it's what I meant to do here is 4. So my rise is 4, and my run is also 4. So that is negative 1 meter per second squared. Now I'm gonna plug it in, and my distance is, I'm gonna do it in red right here on the top. My distance that traveled over the first 4 seconds is 16 meters. So you want to travel 16 meters over here. So that is going to be 16 meters because you want to go back in the opposite direction 16 meters, or the negative displacement is negative 16. And then I have 1/2. Acceleration is negative 1, and I'm looking for the time it's going to take. So the time is equal to the square root of 32, which gives me 5 seconds and 66. And I can plug it in if I want to and check my work. So if I plugged it in and check my work over here, I will have the distance from 6 seconds on is equal to average velocity, so initial is 0, final is initial plus acceleration times the time. I know acceleration is negative 1, and the time I just found out is 5:66 divided by 2, and times the time, which is 5:66. So from here you would see that the distance traveled in the negative direction is negative 16 meters. In other words, it would take you 5:66 seconds to travel with the speed that it has, or acceleration that it has, after 6 seconds to get back to the original position. In this question, they say a block is projected up a frictionless plane with initial velocity v initial, or v sub 0. Let's keep it v sub 0. And the plane is inclined at 60 degrees above the horizontal. What is the approximate acceleration of the block at the instant that it reaches at the highest point of the inclined plane? So I'm going to mark some points A and point B. And look at this triangle that I draw in orange. So H right here is going to be D sine theta. And I can write the potential energy at A. I'm going to assume potential energy at A is equal to 0. And I do have kinetic energy at A. That is 1/2 mv initial squared. Because the block stops all the way at the top, I have potential energy at B is equal to mg, and the height it travels to is d sine theta. And the kinetic energy at B is going to be equal to 0 because it stops. So you can look at the conservation of energy. Your energy at A went into energy of B. So you can set them equal to each other. You can set 1/2 mv initial squared is equal to mgd sine theta. So the mass and the mass cancels. And I have initial velocity in terms of d is equal to the square root of 2gd sine theta. Now I'm going to find out the time it's going to take to get to the top. So the time is the distance over the average velocity. This is initial velocity. Your final velocity is 0, so I need to take average velocity. So the distance is d. And for the average velocity, I have initial velocity, which is 2gd sine theta, or the square root of it, plus 0, and divide all of it by 2. That's going to be the average velocity. So dividing by a fraction is the same as multiplying by a fraction. So 2 is going to go to the top, so I have 2d. And then on the bottom, I have the square root of 2GD sine theta. That's the time. Now I need to find acceleration, because they ask you in the question is, what's the approximate acceleration of the block at the instant that is reaches at the highest point of the inclined plane? So I can find acceleration is equal to change of the velocity. So the final velocity is 0, and initial velocity is the square root of, so minus the square root of 2GD sine theta, divide by, and the time is 2D divided by the square root of 2GD sine theta. So again, I'm dividing by fractions, the same as multiplying by a fraction. So I'm going to have minus the square root of 2GD sine theta times, flipping the fraction in the denominator, gives me the square root of 2GD sine theta over 2D. So the acceleration is equal to, the square root times the square root cancels, so I have 2GD sine theta divided by 2D. So I see I can cancel 2D's from the numerator and denominator. Then I have G sine theta. And theta is 60 degrees, so I have 10 times sine of 60 degrees. So the acceleration is equal to, and in this case it's going to be negative because it's deceleration rate, negative 8.7 meters per second squared. In this question, I'm going to say that if applied force F is equal to 18 newtons, what is the force that this 1 kilogram block exerts on a 2 kilogram block? So if applied force is 18 newtons, that is your net force. So F net is equal to MA. Your net force is 18 newtons. And then the mass, the total mass is 3 kilogram. Then the acceleration is 6 meters per second squared. Then if we look just at the block 2 kilogram, we will see that the block 2 kilogram is accelerating at 6 meters per second squared. Then how much force is the block 1 exerted on block 2? So to calculate this force, I'm going to call it like this F. To calculate that force, I need to have the 2 kilogram mass times the acceleration. So MA is the force, right? So I have 12 newtons. Then 1 kilogram block exerts 12 newtons on 2 kilogram block to make it accelerate at 6 meters per second squared. In this question, they give you block or ball 1 and ball 2 rolling toward each other. And then you can see their velocities before and after the collision in the graph. And then they ask you if the mass of the first block is given. Let's say the mass of the first block, M1, is 4 kilogram. What is the mass of the second block? M2 is the one that you need to find. So I'm going to do the conservation of momentum. Momentum before is equal to momentum after. So I have momentum before is equal to momentum after. Conservation of momentum. Momentum before, I have mass 1 moving with velocity 1 initial plus M2 moving with velocity 2 initial. And after the collision, they're still not stuck together, so there's still 2 of them. So it's going to be M1 V1, different velocity, plus M2 V2. And then I'm going to plug in the numbers. So M1 initial, so this is 4 kilogram, velocity initial is positive 8, plus M2 we're looking for, and velocity is negative 4. From the green graph, you see the velocity it starts with, negative 4 because it's velocity over time graph, velocity over time graph. So then, because the vertical axis is the velocity. And then after the collision, so it looks like collision happens over the time right here. This is where the collision is happening. And then after the collision, we have mass 1, which is the blue one, moving with 4 meters per second in the opposite direction. So the 4 kilogram mass is moving with negative 4 meters per second. And the second mass we do not know, is moving with a velocity of 6 meters per second after the collision. So from here I can find what the M2 is equal to. So I see this is what's happening with my equation. I'm going to move all of my M2 to one side, so I'm going to have 10 M2 on this side and 48 on the other side. So the mass of the second ball is 4.8 kilogram. In this question, I have a block released from rest at point A, slides with negligible friction down the incline track and around the path that is shown. And they ask you where is going to be, if at point A the kinetic energy is equal to 0, at which of these points the velocity is going to be the highest. So if this kinetic energy is equal to 0, then the maximum, and this one is going to be the maximum potential energy because that's the highest point. So that is mg, and let's call it h. So we're going to call this height h. Then kinetic energy maximum is going to be equal to here, which is 1/2 mv at point B squared, and equals to mgh, because all that potential energy will go into the kinetic energy. And at C, you will have some potential energy, so you will have, I'm going to do a different color. So at C, you have potential energy is equal to mg and twice the radius of this circular path. And then the kinetic energy is going to be the rest of it. So there's going to be some kinetic energy there. The same is going to be kinetic energy here, which is at the D, is going to be less than kinetic energy at C because it's higher. So the potential energy at D is going to be greater than the potential energy at C because it is the higher point. And then the kinetic energy at E is going to be greater than at A, but less than kinetic energy at D. And the potential energy at E is greater than the potential energy at D. And if they ask you at which of these points is the kinetic energy closest to the potential energy, I see that D is maybe like 75%, and C is maybe 25% of the potential energy. So the point somewhere in between, C and D would have potential energy is equal to the kinetic energy. The point where the potential energy is half of the initial energy at point A. So right here, the potential energy would be equal to mgh over 2. That means the kinetic energy here is equal to mgh over 2 and 1/2 mass and velocity just at that point squared. In this question, they say a mass on the spring has a maximum kinetic energy, and they give you that maximum kinetic energy. So you see that the block is going to be away from its the spring's equilibrium, which is 0 point, distance A and A, so A minus and A positive on x-axis. I wanted to color my block. And then if I pull the spring away from its equilibrium to position A, then it has a potential energy. So the potential energy of at point, I will say positive A, of the spring is equal to 1/2 K, and this is A squared. The potential energy at 0 of the spring is equal to 0, and again the potential energy at negative A is equal to 1/2 K A squared. So when the potential energy of the spring is equal to 0, this is when you have the maximum kinetic energy of the block. So I'm going to say B for the block, which is equal to 1/2 mv squared. So at the kinetic energy at 0 is equal to 1/2 K A, so Ka squared. And the question is, in this problem, what do I need to do to my problem in order to increase the kinetic energy of the block at 0? Let's not do 4, let's do a different number, by 6. I want to make my kinetic energy 6 times as big at point 0 than it used to be. So I cannot change K. K is the spring. So how far away from the equilibrium should I stretch my spring with the block in order to give the block the kinetic energy 6 times as it used to be before, when I only stretch to the distance A away from the equilibrium. So that would be equal to, again, 1/2 K, and then I have to think, what do I square to get that 6? So I need A, because it's still how many times distance A I have to square or to take away from the equilibrium. But then right here I need the square root of 6. If I square my square root of 6, I will get that extra 6 in front. So I'm gonna get equals to 1/2 K, and square root of 6 squared gives me 6, and then I have A squared, which gives me 6 times the kinetic energy I used to have initially. So I have to stretch my A additional distance, and that distance would be equal to the square root of 6A in order to get 6 times the kinetic energy of the block I used to have when I only stretched the spring the distance A away from the equilibrium. And thank you for watching this video. If you in the future find questions on college board review quizzes that you don't understand and you want me to explain, please email me and let me know which ones you would like me to explain. I changed the questions, so they're not exactly the same, but I try to stay within the concept so it helps you to study. And thank you for watching, and I'll see you in the next video.